Hello and welcome to all of you in my channel Blue Chip Finance, and in this video we are going to discuss about one more technique of forecasting, and that is tracking signal. So tracking signal is simply a measure of deviation, or you can say that measure of dispersion. In this particular section of forecasting, we use tracking signal uh, to track the deviation or dispersion of actual data and forecasted data. So the answer may be in minus or plus, or we can calculate also range of deviation through tracking signal. So here we are going to take one example from the book J. Hazer, Operation and Production Management, and that question is that data related to 8 quarters of Baltimore is given below, with actual tonnage unloaded and forecasted tonnage unloaded, with smoothing constant alpha equals to 0.10. Calculate tracking signal. He guesses that the forecast of grain unloaded in the first quarter was 175 tons. So actual question is, this first column is representing quarters time period, and second column is representing actual tonnage unloaded. And this forecast we calculated by ourselves. If you don't know about the calculation, that how can we calculate this forecast with smoothing constant 0.10, then you should go to the previous video and previous maybe 1 or 2 videos in which we learn to calculate the forecast with alpha equals to 0.10 or maybe 0.30 somewhere in previous 2 videos. So now from here our question of tracking signal is started. So first step is to calculate the error. So error is the difference between actual minus forecast. So 180 minus 175 equals to 5. 168 minus 175.5 is minus 7.5, and 159 minus 174.8 is minus 15.8. so it is the first step to calculate the error, and at the end you should take the sum of this error, that is 35.9. After that, second step is to calculate the cumulative error. It is very easy to calculate, just as you calculate the cumulative frequency. Similarly, you can calculate the cumulative error. That just take the first value of error here, 5, and 5 plus minus 7.5 equals to minus 2.5, minus 2.5 plus minus 15.8 equals to a minus 18.3, minus 18.3 plus 1.8 equals to minus 16.5, and just similarly in the same way you can calculate the rest of all values. So in third step we calculate the absolute forecast error. What is the difference between absolute forecast error and simply error? When we ignore the minus sign from error, from the calculation of error, that is actually the absolute forecast error. So just remove the minus signs from it, and the result will be your absolute forecast error, actual minus forecast, and just ignore the minus signs and take the sum. Sum is 82.45. so from here we can calculate mean absolute deviation. and mean absolute deviation is equals to sum of actual minus forecast, or you can say that absolute forecast error, that is 82.45, and divided by n, and in your time period, so there are 8 quarters, so 82.45 divided by 8 equals to 10.30625, and that is mean absolute deviation. And after that, tracking signal is equals to sum of error or cumulative error divided by mean absolute deviation. So your sum of error or cumulative error, here sum of error is 35.9 and cumulative error is this last value, that is equals to 35.9. so you can say that it is sum of error or last value of cumulative error, and divided by mean absolute deviation, 10.30625 equals to 3.48. so that is your tracking signal. There is a deviation of 3.48 plus in between actual values and forecasted values at smoothing constant alpha equals to 0.10. But if you want to calculate the range of tracking signal, then you go further. And how can we calculate the range of tracking signal? So if we want to calculate the range of tracking signal, our next step should be to take the cumulative absolute forecast error, and the method is same as we discussed when we calculated this cumulative error, that just take the first value of absolute forecast error, that is 5, and just add up the next coming value of absolute forecast error into previous cumulative absolute forecast error. So just take the first value 5 here, 5 plus 7.5, 12.5, 12.5 plus 15.75 equals to 28.25, 28.25 plus 1.82 equals to 30.07, and so on. And here you can say that last value is 82.45, that is equals to absolute forecast error. Now your next step is to calculate the individual level mean absolute deviation, and that is equals to cumulative absolute error divided by your current time period. So here cumulative absolute error is 5, and you are calculating for first quarter, so 5 divided by 1 equals to 5. Second cumulative absolute error, forecast error, is 12.5, and 12.5 divided by second quarter is equals to 6.25. Similarly 28.25 divided by 3, 9.417. 30.07 divided by 4 is 7.5175, and so on. Now your last step is to track the signal, and that is equals to cumulative error divided by mean absolute deviation at individual level. So what is your first cumulative error? And that is your first cumulative error is equals to 5, and 5 divided by mean absolute deviation. Mean absolute deviation is also 5. Here you can see it is equals to 5. So 5 divided by 5 equals to 1. Your second cumulative error is minus 2.5 divided by 6.25 equals to minus 0.4. For third time period, minus 18.3 divided by 9.417 equals to minus 1.94. And through this method you can calculate the whole range of tracking signal, and you can see that there is a variation which is started from minus 2.19. it is the extreme value of the minus side, and the plus 3.48. so through this method you can calculate the tracking signal for range if you want to calculate the range of your deviation, uh, it may be from plus to plus, or it may be from minus to plus. So here extreme value to the minus side is minus 2.19, or you can say maximum value of the minus side is minus 2.19, and the maximum value to the plus side is 3.4548. so it is the range. And if you want to calculate only the plus side range of tracking signal, so you can calculate through this very easy method, and that is 3.48. So that was the calculation of tracking signal. In the next video we are going to discuss about some more about the moving average for forecasting. So stay safe and stay blessed. Take care of yourself. Thank you.